Okay, so this problem is number 67 on page 348. So we got a balanced equation. We have a mass of butane. So we have a butane, we have 55.2 grams of butane. So that's what we have. We're asked to solve for what? What's this wanting to be able to find?
Volume.
Volume of what?
Oxygen.
So we need to find a volume of oxygen that would be required to react with that 55.2 grams. So we want this all gone. So what they're asking is they're asking for this volume in liters. Now, to do that, we're going to have to use the ideal gas law. Okay? So let me write the ideal gas law out. For you that were gone on Wednesday and Thursday, this is the law that we use. Okay, so we know pressure, we know temperature, we're solving for volume. We don't know moles. Okay, so that one we do not know. And we know R, right? What would be R for this one?
0.0821.
Okay, so if you were gone on Thursday, we said that R is a constant. And there's 3 R's. And the one we're going to use is 0.0821. Okay? Now, if you were gone on Thursday, this is going to be tough for you guys to understand because I'm not explaining things as detailed. So that's why you got to go watch the video or get help from somebody in class that knows what's going on. So 0.0821, we have that. We don't have the moles. Does anybody have an idea how I could find moles of O2?
You have to do the gram to mole.
Right. Kind of like on the last lab we did. Remember the last lab we did? We had like 0.042 grams of magnesium, and we had to convert it to moles, and then we had to figure moles of hydrogen gas. That's what we're going to do here. So that concept, what we're going to do is we're going to take that 55.2 grams of butane, and we're going to change it to moles. So, off the top of their head, does anybody know the molar mass of butane?
It's
Figured out.
58.
58 point, I think it'll be 1.8.
It was, yeah, actually it was 58.04, isn't it?
If you take hydrogen as 1.01, then you'd have to add in some more of those. So, be 58.18 grams is equal to 1 mole of butane. So, we're not there, right? So, what do we need to do in our next step? So, we're here. We got moles. So, now we got to go over here to get moles. So, what are we going to have to do to go from moles of butane?
2 moles.
So, down here we'll have to have 2 moles of butane, right?
Yeah.
And up here we'd have 13 moles of oxygen. So then I have my moles of oxygen that I can plug in there, and then I've got all my information to switch my equation around in which to solve for what I need to solve for. Okay? So I'll get my moles. So on these problems, you guys will have to understand you're going to have to do some sort of a mole relationship somewhere along the way. Okay, somewhere you're going to have to use that equation, do a mole to mole, mole to gram, somewhere along the way in which to come up with your final answer. So we're kind of connecting 2 concepts, one that we've done in the past with the ideal gas law, in which to figure out amounts of products and reactants when we got different pressures and temperatures involved. So it's 6.17 moles. So now all we do, for those who were gone, we would go ahead and go the volume is equal to nRT over P. So N is 6.17. R is going to be 0.0821. T is going to be 298. Again, some of you on the last assignment, you were not converting. You gotta make sure you do that. Divided by the pressure, which is 0.85. And then you got your answer. $178 liters. They may have some questions that you got to work backwards. So here, let me give you an example what I mean. I'm not going to do one for you. But let's say it says, I've got 50 liters of oxygen. How many grams of butane will burn? So what you'll have to do is go backwards, right? And you'll have to take the liters of oxygen under those conditions to find what? How am I going to get to figure out how much butane is going to burn if I have 50 liters available? What unit am I going to have to solve for to get over here? To solve for something I can go and do a ratio with. So what would I have to get it back to? Moles. And then I can do a mole to mole, mole to gram, and I can figure it out. Okay, so all these problems you're going to be going through moles at some point in time to do it. Okay? So for tomorrow, you can write these in your notes. These are the problems that you'll do. Okay? On that same page. Page 348. Now,
Are we turning these in?
no. Now, the lab, you're supposed to come up with a number that's 58 grams per mole. And the other two classes, I allowed a 20% error or less. So if you have a 20% error, and the reason why it's such a bigger error, we're not dealing with a very big mass. It's like 0.08 or 9 grams that we're using. So I'm going to allow about a 20% error or less. I'm not going to take any points off if you show all your work. Show both trials. I want to see both trials. Even though one might be way off, hopefully you've got one of the two trials that's fairly close within that 20% range.
Yeah.
Okay? And you guys can work on that or work on the assignment, whatever you want to do. If you did not do the lab, I'm going to help you do that lab real quick so that you can have the information before you go.
Do you want us to turn that one homework assignment?
Yeah, you got that as one done, you can turn that one in.